So now that we know how to convert Avogadro's number to moles and moles to Avogadro's number, now we need to learn how to do the mass to mole conversions. The relationship between 1 mole and the mass of a compound is what I'm going to explain. The formula weight is the sum of atomic weights of all atoms in a compound reported in atomic mass unit, what we did previously. And that formula weight is what's gonna relate to 1 mole. Let me just give you a quick example of H2O. Now in H2O, the mass of hydrogen, the atomic mass of hydrogen is 1 atomic mass unit. Another hydrogen is 1 atomic mass unit. The mass of oxygen is, according to our periodic table, mass of oxygen is supposed to be around approximately 16 atomic mass unit. Now if we add all these, it will give us approximately 18 grams mass of the water. Okay, now that 18 grams is what we are going to call it 1 mole of water. That's the relationship. Now if you take CO2 for example, the atomic mass of carbon in the periodic table, let me show you the periodic table. So carbon is right here. The mass of carbon is gonna be the bigger number in the green box, which is 12.011. 6 is the atomic number, that's number of protons. We are going with number of protons plus neutrons, which will give us 12.011 for carbon. So carbon is 12.011 grams. Okay, and then we have 2 oxygens. Now you can approximate each oxygen to have a mass of 16, mass of protons and neutrons in oxygen atom. Take it to be 16. Here, if I look at it, it's telling me 15.99999. So I'm just estimating to give you the idea. The mass of CO2 here, if you add all these, is gonna be approximately 44. Now what we'll say is 44 grams of CO2 is equivalent to 1 mole of CO2. So that is what you're going to be doing in this section, mass to mole conversions. How to calculate the formula weight of a compound is going to be basically what I've done in red in these spaces. But let's do an example. Calculate the formula weight of iron sulfate. Iron sulfate is FeSO4. The step 1 will be to write the correct formula and determine the number of atoms of each element from the subscripts. Now the formula we are given is FeSO4. This can be written as Fe subscript 1, 1 atom of Fe, the ion, S subscript 1, 1 atom of sulfur, and then O subscript 4. All these will translate to 1 Fe atom, 1 iron atom, 1 sulfur atom, and 4 oxygen atoms. Okay. The second step will want us to multiply the number of atoms of each element by the atomic weight found in the periodic table and add the results. This atomic weight is read from the periodic table. So when doing this, you have to use a periodic table. Okay, so 1 Fe has a mass of 55.85. Let's see. Fe is right here. Yeah, it's 55.845, 55.85. You can see it here. It's right here. And then sulfur is right here in the big green box here. It's 32.06. Oxygen should be 15.999, which is roughly 16. So we go back here. You see we have 32.06, we have 16, this is an estimate of this number as found in the periodic table, but personally, when doing problems, we don't want to estimate so much. Use the atomic mass you're given in your periodic table in the test. So since we had 1 Fe, just multiply by its corresponding atomic mass unit. So iron will contribute that much in iron sulfate. This is actually iron 2 sulfate. We have 1 sulfur, we keep the 32.06, that's from the sulfur, and then we have 4 oxygens, so 4 times 16 is 64. These comes from 4 oxygens, and then we are told in this step to add them up, do the sum. The formula weight is just the sum of all those to be 151.91. So in this case, we say that 1 mole of iron 2 sulfate is actually relating to 151.91 atomic mass unit, which is just 151.91 grams of iron 2 sulfate. So it is okay for us to summarize all these sentences and say the formula weight of iron sulfate, iron 2 sulfate is 151.91 grams per mole. This is 1 mole of iron sulfate, so 151.91 grams per mole of iron sulfate. Okay, so what we are trying to say here is that to find the molar mass of a compound, you need to firstly find the atomic mass of a substance and sum them up. So the molar mass is the mass of 1 mole of any substance reported in grams per mole. For example, as we just saw, iron sulfate molar mass or molar weight or formula weight, whichever way you call it, is 151.91 grams per mole. Grams per mole. That much grams of iron sulfate is 1 mole. Now remember, for water, we found out that the molar mass of water was 18 grams per mole, which is why we need the mole to compare these things. And then for CO2 was 44 grams per mole. So the grams are different, but they are all 1 mole. Water is 18 grams per mole. CO2 is 44 grams for 1 mole. And then here, iron sulfate is giving us 151.91 grams for 1 mole. Okay. The value of molar mass of a compound in grams per mole is equal to the value of its formula weight. We've determined that. Now, the periodic table here is just reminding you that when you're reading the atomic masses, go for the bigger number in the box. And in this case, since this is an atom of carbon, so the atomic mass, we now don't say the formula mass, we say the atomic mass. Formula mass is when you're relating to a compound. Molecular mass is when you're relating to a molecule, and atomic mass is when you're relating to an atom in the periodic table. The atomic mass of carbon is 12.01. What that means is that for every 12.01 grams of carbon, that is really 1 mole of carbon, and so we can easily say 12.01 grams per mole of carbon. Let us continue with part 5.6b, talking about relationship of grams and moles, relating grams to moles. So we can now infer that the molar mass of a compound or a molecule relates to the number of moles to the number of grams of a substance. Again, I'll repeat myself. If I really want to find the molar mass uppercase M of water, it's just adding the mass of hydrogen, the mass of oxygen, which is 16. It gives me roughly 18 grams. So we are saying that 18 grams of H2O per mole of H2O. So simply put, the molar mass of water is 18 grams per mole. So it's true. Then molar mass relates the number of moles of a substance to the number of grams of the same substance, as you've seen in the case of H2O, and also as seen in the case of iron sulfate, where we found that it is 151.91 gram per mole of iron sulfate. This is very important. This fact is very important because now we can have a conversion factor to work with. The molar mass of water exactly is given as 18.015 grams per mole. I was just approximating it to 18. So you can say 1 mole of H2O is 18.015 grams of water. Alternatively, do the inverse of this. You say 18 grams of water is equivalent to 1 mole of water. So how do you know which one to use? Use the one that gives you the answer you're looking for. So if you're doing your calculations and you want to end up with moles of water, then use the first conversion factor. If you're doing your calculations and your answer needs to read grams of water, use the second conversion factor. That's how you know. Let us work on a sample example relating the formula mass to the moles. The question reads, how many moles are present in 100 grams of aspirin, your painkiller, with the formula C9H8O4? The molar mass of aspirin is given as 180.015 grams per mole. You can see the grams is related to 1 mole. Okay, before we said the Avogadro's number of particles relates to 1 mole. That is the root and definition of 1 mole. But now we are saying a given mass of a compound as found by adding the composite masses of the elements of that substance or that compound is equivalent to 1 mole. So we are told that aspirin has this much mass. And if you want to get the 180, it's simple. Just take the mass. You see this formula right here? Take the mass of carbon times 9, and then add the mass of hydrogen times 8, and then add the mass of oxygen times 4. And let's do that and see. So just by approximation, take carbon to have a mass of 12 times 9, and then take each hydrogen to have a mass of 1 times 8. That's from the periodic table. And then take each oxygen to be 15.999 times 4. Add them up. All these numbers, I got them from the bigger numbers in these boxes, like oxygen is 15.99, carbon is 12, approximately 12.011. Hydrogen is right here, 1.008. So I just used 1. If you add those up, this I believe is 108. This gives you 8. And the other one will be, let me do 15.99 times 4. So this one is giving me roughly 63.996. Add all those up. What will you get? Let me delete this. Add all those numbers up. What will you get? The answer I'm getting is 179.996 grams. Okay, which is just close to 180.015. It just depends on how many decimal places or the numbers you're approximating here, but usually, again, you don't want to approximate that much. I'm just giving you an example on how this number was found using a periodic table. Okay, so we read again the question. I diverted. How many moles are present in 100 grams of aspirin, given the molar mass of aspirin is 180.015? So what I'm given here is the mass of aspirin sample. Also given here is the molar mass of aspirin, and is given as 180.015 grams per mole. What I need, the needed is moles. Okay, so that's a given quantity. This is the needed or desired quantity. Now, since I'm looking for moles, what I'll use as a conversion factor will be 1 mole of my aspirin is having a mass of 180.015 grams, which is just what you're given here, 180.015 grams per mole, but I'm switching it to moles per gram. Okay, and then I can multiply this by the grams given in the question, which is 100 grams of the asp. That is a quick setup of it, and you'll see it in the next slide. This way the grams and the grams will go, and all you're left to do is to do the math here to find your answer. So let's see. So step 2, you're going to write out your conversion factors, which is what I did. I'm looking for moles, so I'm going to go with this conversion factor, not the other inverted one, because I want to end up with moles. And the reason is I want to cancel some things. Then now, that's the conversion factor I chose. So this is the given mass that we need to convert to moles. So the grams and the grams will cancel out. That's how you know you used the correct version of the conversion factor. When you divide, this is what you should get. It reported in 3 significant figures. Okay, remember all unwanted units must cancel. So that's how we do this. So 100 grams of aspirin is really equivalent to 0.555 moles of aspirin. That's the conclusion here. The answer we are looking for is this right here. Okay, so that's how you relate your formula weight to moles and even use it in calculations to find if you're given a given mass other than the molecular weight of the sample, can you find the corresponding moles of it? Now let us do 2 examples relating the formula weight or molar mass to moles in some sample calculations. So question number 1 reads, how many grams of calcium carbonate are in 5.6 moles of a calcium carbonate sample? So I can note down the given. So what I'm given here is moles of calcium carbonate, and what I need, the desired answer, is gonna be in grams or mass of sample. We are going to follow our 2 steps. So step number 1 here is to determine or calculate the molar mass. Calculate the molar mass of calcium carbonate. I know that I have 1 calcium, the subscript implied 1 there under the Ca. I know I have 1 calcium, I have 1 carbon, okay, calcium 1, carbon 1, O3, and then I have 3 oxygens. So if I need to find the molar mass, I'll have to add not the atomic numbers, but the molar masses of this. Looking at the periodic table, calcium has a molar mass of 40.098. So I'm looking at calcium right here, 40.098. Sorry, 40.078. So 40.078 grams is the atomic mass of calcium in the periodic table. Then I go to carbon. Carbon is right here, 12.011. There's only one of it, so 12.011. And then I have 3 oxygens. Each oxygen is 15.999. It's right here, 15.999. Let me highlight it. There's the oxygen. It's 15.999. There's 3 of them. Now let's add all these grams up. These are atomic masses, and that's gonna give us the molar mass of calcium carbonate. Do that with me. So the answer I'm getting is 108.086 grams, and that is equivalent to 1 mole of calcium carbonate, so it's a grams per mole. Now that is important because now I have 2 conversion factors. My conversion factors, the first one is 108.086 grams is equivalent to 1 mole of calcium carbonate, or I can say 1 mole of calcium carbonate is equivalent to 108.086 grams. So which one do you think we should use? The question is asking for how many grams, right? That tells me that I should be going with this because that one has the grams as the numerator. This is what I'm gonna go with, not this conversion factor. And so we'll take 5.6 moles calcium carbonate multiplied by the conversion factor 108.086 grams calcium carbonate is equivalent to 1 mole of itself. Now this is important because now we know these moles will cancel out, and the answer here will be 6 or 5.2816 grams calcium carbonate because that unit did not cancel out. However, if you look at the problem, we are given the value in two significant figures. So our answer in two sig figs, which is this point, is gonna be 6.1 times 10 to the power, the 5 here will help us to upgrade the 0 to 1. But the decimal here is gonna go 2 points to the back. So it's 10 to the power 2 grams of calcium carbonate. And that is the answer. So what this answer tells me is 6.1 times 10 to the power 2 grams of calcium carbonate is equivalent to 5.6 moles of calcium carbonate. Let us look at the next example, which reads question 2. How many moles of water are equivalent to 150 grams of water? Good question. So always I go with the given. What am I given? I'm given mass of water, and the mass of water happens to be 150 grams of water. Okay, what do I need? Needed is gonna be moles of water, grams of water, moles of water. So step number 1, as usual, or step A, we need to find the molar mass of water using the periodic table that will be given in the test. So the periodic table that I have here will help me to find the molar mass by adding mass of hydrogen atom plus mass of hydrogen atom plus mass of oxygen. And my molar mass M is going to be equal to, my molar mass of hydrogen here seems to be 1.008. So I'm going to bring it here, 1.008 grams plus 1.008 grams of atomic mass unit plus that of oxygen we already saw is 15.999. I only have one oxygen, so I'll say 15.999 grams. Let's add all those up, see what we get. So the molar mass I'm getting is 18.015 grams, and that is equivalent to 1 mole of water. This much mass, that's the formula mass or molar mass, is equivalent to 1 mole of water, which is what we're talking about in this section. Now step B, I can actually now solve the problem using conversion factors. So the conversion factors in this case are simple. Based on the molecular weight, I can do 1 mole of H2O over or per 18.015 grams of H2O, or I can do 18.015 grams of H2O is equivalent to or per 1 mole of H2O. Which one should we use? We are asked how many moles. So I should be going with the first conversion factor. That's what I need. I need to use this because the numerator has moles of water. so ignore the other conversion factor. And to solve it now, I will bring my 150 grams. Let me call this 150 dot grams of water. The question is asking how many moles of water are equivalent to 150 dot grams of water. So 150 dot grams of water times the conversion factor. I'm going towards the mole, so 1 mole per 18.0185. You do the math, what do you get? The answer I'm getting is 8.326 moles of H2O. Why moles of H2O? The grams will cancel out. Now I see that I have three significant figures in 1.50 dot. The dot here now qualifies the zero to be significant. If you write it as 150, that would be two significant figures. We talked about that already in earlier chapters. So the final answer here in three significant figures will stop at the 2, which we see that 6 is greater than 5, so it will be 8.33. The 2 is rounded up to 3 moles of H2O, and that's our final answer right there that we were looking for.